Question number 9 is an interesting question. It's basically June 21, paper 1, 2, and question number, it is 9. Oh, okay, it's June 1, paper 1, 1, sorry. It's paper 1, 1, question number 9. June 21, paper 1, 1, question 9. It shows a graph relating two quantities. One of them is P and the other one is Q. The first thing is they're asking that what quantities could be P and Q. Now, first of all, you have to see if P is increasing, then Q is decreasing. And if Q is increasing, P is decreasing. So first of all, you have to observe which two quantities are related like that. So if we go for option B, option B is something that you have studied in your syllabus. There are some options which you studied in your class notes or syllabus, while there are some other options which you may not have studied. So this is a question in which some options are there which you already studied and you know them. So acceleration time graph for the motion in air have been studied, and it is generally taught by the teachers in the classes. And this is a graph like this. Acceleration goes to 0, but at a decreasing rate. There's no need to explain this. It is eliminated because you studied this in your classes. Now, what about velocity? When something is falling, there are two possibilities. The velocity could be increasing or it could be a terminal velocity. And one thing, the air resistance increases with increase of speed or velocity. So they both increase together. So this is not the option. And what about velocity? We have two possibilities. Velocity either increases during the fall. For example, if it's a vacuum or the terminal velocity is not achieved, or it could be constant. So if you draw a graph of velocity, then either it will increase or it will be constant. D is not the option. Now, if I say since all other options are wrong, then A is the answer, it will not make a sense. We need to understand why A. Basically, we need to write the equation for resultant force. When something is falling in air, the resultant force on that something will be, for example, if we have a ball that is falling in air, the resultant force will be weight is acting downwards and air resistance is acting upwards. And weight is the constant force, air resistance is the variable force that varies with variation of speed. So the equation would be resultant force is equal to mg minus air resistance. And now, if we write resultant force as MA is equal to mg minus force of air or air resistance, then the final form of the equation for acceleration will become mg over m minus air resistance over m. So the variables are, there are two variables. The air resistance is the independent variable and the acceleration is the dependent variable. Everything else is constant. So the equation for acceleration becomes A is equal to minus 1 over m times air resistance. And then it will be minus g. We have simplified the above equation. Now you see, if we plot a graph of acceleration on the y-axis and air resistance on the x-axis, what would be the shape of the graph? If we compare the given relationship with the equation of straight line, it will become, this is y, this is x, independent variable and dependent variable. This would be the gradient. This would be the, in the next exam, they may change some factors, like they may say, if the object is heavier, then what would be the effect on the shape of the graph or something like that. So you need to understand the concept. So it will be y is equal to mx plus c. So if we make a comparison of the two equations, then the comparison will become, we can write y is equal to mx plus c. Here y is the acceleration, x will become the air resistance, and with the air resistance we have negative 1 over mass of the object that is falling, and y-intercept will be, here we are getting negative g. So according to the relationship, what we are getting is, sorry, it was plus g. It was plus here. Sorry, students. So plus g. So the shape of the graph will be, it will be acceleration on the y-axis, air resistance on the x-axis. It's a graph with a negative gradient, and it will start from plus g, and the shape of the graph will be like this, and the gradient of the graph will be equal to negative 1 over mass of the object. This is the idea. So according to this idea, the equation that is correct, the option that is correct, it is option A. I hope it should have been understandable. So we wrote the equation, then we simplified that, and then we compared that to y is equal to mx plus c. We have observed that if we plot a graph of acceleration against air resistance, the y-intercept is plus g, and the gradient is negative of 1 over mass of the object. This is the idea here. Okay, students.